This is an integrated question involving the division algorithm, the remainder theorem, and the factor theorem. Let's see what the question tells us. First, x minus 1 is a factor of p of x, which is a cubic polynomial, meaning that its degree is 3. Next, when p of x is divided by x, the remainder is 5. Last, when p of x is divided by x minus 2 times x minus 3, the remainder is 19x minus 37. Part A, we need to find the quotient when p of x is divided by x minus 2 times x minus 3. The first step we'll do is to set up a polynomial of p of x by the division algorithm. And to do so, we'll let something to be the quotient first. Before we can do that, we'll need to know the degree of the required quotient. Okay, note that the dividend, p of x, is a cubic polynomial. That means it's of degree 3. And the degree of the divisor is 2, meaning that it's a quadratic polynomial. When a cubic polynomial is divided by a quadratic polynomial, the quotient will be a linear polynomial. Or in other words, when a polynomial of degree 3 is divided by a polynomial of degree 2, the quotient will be a polynomial of degree 1. So now we know that the quotient is of degree 1. We can let ax plus b be the quotient. The question has given us the remainder, so we can express the polynomial p of x by the division algorithm. By finding the values of a and b, we can find the required quotient. We'll need to use the two other pieces of information from the question. The remainder is 5 when p of x is divided by x. By the remainder theorem, p of 0 is equal to 5. So we have b is equal to 7. Also, x minus 1 is a factor of p of x. By the factor theorem, p of 1 is equal to 0. We've already got that b is equal to 7. So we can find that a is equal to 2. Therefore, the required quotient is 2x plus 7. Part B, we need to find the number of rational roots p of x equals 0 has and explain it. Recall that a rational number is a number that can be expressed in the form of p over q, where p and q are integers and the denominator q is not equal to 0. We can use this 4-step approach. Step 1, factorize p of x. Step 2, solve the cubic equation p of x equals 0. Step 3, determine the nature of each root. Step 4, write down the conclusion. By the result of part A, write down p of x first. We've already known that x minus 1 is a factor of p of x. Use long division to factorize p of x. Then p of x can be rewritten as a product of x minus 1 and a quadratic polynomial. Next, solve the equation p of x equals 0. Here, either the first factor, x minus 1, equals 0, or the second factor, this quadratic polynomial, equals 0. Finally, we'll determine the nature of the roots to see if they are rational. The first factor gives the root 1. Obviously, it's a rational number. For the second factor, as we want to determine whether the roots are rational. We'll use the quadratic formula to find the exact values of x. But not finding the discriminant because the discriminant can only tell us the number of real roots. It can't tell us whether the roots are rational or irrational. Clearly, these two roots are not rational numbers. So the only rational root is 1. Lastly, write down the conclusion. Therefore, the equation p of x equals 0 has one rational root. That's it.